Hello, everybody, and welcome to today's OpenONU Go call. Thanks for joining. As usual, the call is public and recorded. It will be shared live on YouTube, so please be mindful of the comments you make and the information you share, given that it will be public. So first of all, I'd like to make a plea to everybody. Yesterday in the TST, we discussed the Kafka to gRPC migration, and we agreed that there will be 1 week from now on which everybody would focus on this migration, given that there are some errors and things that we're seeing out of the tests. Mostly, these are actually existing bugs in the code base that have been uncovered by the faster/different speed of gRPC. And so in the next week, we will try and get all of these fixed. The key elements that we are seeing failures on are the reconciliation tests of the OpenONU Go adapter. That is because they actually throw in a series of very particular scenarios and very good to test scenarios. And so we're hitting some problems over there. Also because sometimes they seem very much time sensitive. Maybe Theo, David, Girish, anybody wants to give some thoughts on this? You guys have spent some time yesterday focusing, and the days before, focusing precisely on this. So maybe you can give us some more insights.
Do you want to take a stab?
Yeah, sure. So basically, the tests we are focusing on right now are the tests in the OpenONU reconcile for the OpenONU adapter Go test suite. So basically, reconciling, inserting OpenMCI, reconciling in initial MIP downloaded, etc. That test suite. And what we were seeing yesterday evening, but with results that are not exactly consistent around the board in different scenarios, is that the reconcile inserting OpenMCI seems to be pretty stable now that we made a patch on the robot testing to fix the process. Basically, there was an issue in which we were not waiting for the unit ports to be reported to ONUs before checking for the existence of the default meter in the case of the AT&T workflow. And because of that, the test was not finding the meter and failing. But the process was actually succeeding. So it was just a matter of getting the test to wait for the right condition. The second test, reconciling initial MIP downloaded, it was working very reliable for me yesterday, but that was not consistent. So I believe there is some timing issue in there. We found 2 issues yesterday while working on that test. The first one is that the flow fails installation. So Volta reports that no flows are pointing to the default meter, and ONUS removes such meter. We are discussing a possible solution to that in the Kafka channel for now. Anyway, for this first issue, there is a workaround that is configuring ONUS not to delete the meters if there are no flows pointing to them. And with that set and a fix from Ken, I see the flow, I see the test passing, or at least it was yesterday. I haven't run it today. I just rebuilt with the latest code, and I'm gonna try.
One quick question on that one, Theo. Why are we taking up to a minute to install the flows? Do you have any thoughts?
Because the flows lands in the core. The adapter is still restarting, is not yet connected to the core, and so we cannot proceed and install the flow. The main difference with the Kafka behavior is that with Kafka, the core was accepting the flow, putting the messages on the bus and calling it a day and reporting to ONUS that the flow was installed.
Yes.
But then the flow was actually installed once the adapter started, so that it was landing in the device basically at the same time as with gRPC, just the delays in a different place.
I see. Okay, thanks.
Okay, so I think
But basically, we're reporting to ONUS that the flow is installed when all we really meant was we accepted the request.
Yes, with the previous implementation, that is the case. Yes.
Yeah.
So I think we are pretty good on track on figuring out that test. We know exactly what is going wrong. The other thing that we did to fix that test was that we weren't clearing the flow cache in the RW core if a flow was failing installation. So the flow was reported back to ONUS, even if it was failing the installation, and so ONUS was not pushing it anymore. That has been fixed, so I'm pretty confident we should get this test to pass consistently very soon. Then there is a third test that we were looking at, that is the next one in the suite, reconciling MCI flow pushed. This is a kind of a complex workflow, meaning that we basically create and enable the OLT and OpenONU. We perform the sanity test. Then we kill the OpenONU adapter. We waited for it to restart, and then we run the sanity test again without adding the subscriber. So now with gRPC, these tests succeed very, very quickly because the device status has not changed when it goes in reconcile mode, because the core tries to initialize a reconcile, but the adapter doesn't receive the message until the gRPC connection is established. So the device state is never set to reconcile until the device comes back online. Sorry, until the adapter comes back online. So this test runs very, very quickly, and we then immediately try to disable the new device, but that fails because the device is actually in reconcile mode. So the core fails that request.
So one question on this, and maybe this is more of an approach question rather than just in general, maybe this goes to David as well. If the core decides that the device should be in a certain state, given that the core is kind of the master of all things, shouldn't we put it in that state even though the adapter did not reply to us? Before, I mean, we put it in that state with the core continues to try to ping the adapter to make it that state, but it reports that state in the upper layers. I don't know if I made myself clear.
You're suggesting that the core does continually retries to communicate to the adapter, but already reports back to ONUS that the flow's good?
Not the flow.
No.
Not the flow, the device. So in this case, we're saying, the device should be in reconciling state. The device should be in reconciling state. Okay, we are not putting it into reconciling state, even though we think it should be, because the adapter does not reply to us. But if the core thinks that the device should be in reconciling state, I think it should set it into reconciling state in the device state and continuously retry, because that is what the core wants to achieve. And thus all the upper layers should know that the core is trying to achieve reconciling state.
So reconciling state is an operational state, correct? And I thought
Yes.
all operational states are set by the adapter, all but one, I thought.
Yeah, I remember these discussions because we spent quite a bit of time talking about reconciling a few months back. But I think that if the adapter is not there, it cannot set the opera state in any way.
Yeah. So the operational state is supposed to reflect back what the adapter thinks. There's also an admin state, which the core can set. I thought there was an admin. I don't know if there's an admin state that indicates the
So
device is unreachable or whatever, right?
The way the core knows that the device is reconciling is that it keeps a transient state.
Yep.
And that's
Right.
the one that fails the request, but that is not exposed via the API. So the test have no way to know that the device is actually reconciling.
So what's the operational state during this failure?
It hasn't changed. The state is active.
Active. Okay, so the
well, because theoretically the device is active, because nothing has changed in its flow. You can still pass traffic through it.
So
it's actually unknown, right? I mean, we don't know if the device is still passing traffic. We can't talk to it.
Fair enough, but if nothing, actually, unless someone rebooted the device,
or power out, or several other, or cable breaks, or there's lots of reasons. It really is unknown.
Yeah. That could also be an OMSI configuration which was not finished before the reboot. So it could be also an inconsistent state between ONU and ONU adapter in this case.
Okay, yeah. Makes sense to say it's unknown because we cannot talk to it, so we don't know.
Then should the core move the state to unknown in this case, and we move the tester to check that state? Would that make sense?
The tests are already checking that the state is active. That's why they are passing so fast. So if we move the state to something else until we know that the device is active, that will solve the issue.
Well, then
I mean, I could argue that from an operational state, it's reasonable to have an unknown operational state, in which case the core could set it. And it's basically saying, I have no idea what's going on because I've lost communication.
Don't we already have such state? I thought we did. Unknown. Maybe not. Maybe it's my bad.
Yeah, we do.
Yeah, then I think we're good. We just move it to unknown.
To all the, for all the devices that are managed by the adapter.
For all the devices that are managed by the adapter, we just move it to unknown because we just don't know.
I think it has to be checked which state will be set, and when this reconciling state, the reason is assumed. But
okay, so should we make this change and try again with the test?
Yes.
But who makes the state active again? The adapter makes it active once.
The operational state is the core that acts on it. So whenever it reconnects to the adapter, it sees if the device shows up again and changes the state. No?
No. Oh, the adapter changes the state. No, the operational state, I think any change from unknown should come back from the device.
Yeah.
Well, but from an adapter perspective, nothing changed. So it should be the core that, in case of unknown, does like, where was I before? What is the device reporting to me?
You're assuming it's going back to the known state. It may not be there. You're unknown. The only way you know what that next state is if the device tells you. You can't assume that it's in the same state it was before you went unknown.
Yes, but then we should, whenever the adapter comes back, then we should ask the adapter which state it thinks the device is in.
No. I think the adapter reconciles with all the devices that it manages. I think
Okay.
it does the MDS check or something like that, and then it updates the state. And then it takes it from source.
Will it send a state update?
That I am not sure. I think it should. We'll have to check.
Okay.
I guess not for the moment, because what we are doing with my understanding is that we just say reconcile success or something like that. And we assume that no other state is changed in the meantime. So that is something that has to be built in together with the reconcile success, something like that.
Okay, so if the reconcile is successful, the adapter knows what the state of the device is.
Yes.
So then we can maybe make the change to send that state up.
But reconciles success doesn't mean that the operation state is active. I mean,
No, but
as I
of
said,
course
yeah, go ahead, Ol.
Yeah, of course not, but the adapter knows in which state the device is.
So it just sends back whatever it thinks whatever the knowledge it has.
How does the adapter knows in which state was the device before we set it to unknown?
Because we store the current state of the device. We need to do that because we have to have the same data after reconcilement, after restart in the adapter as before the restart, in order to.
So the adapter stores its own state in etcd, and we can use that to set the opera state to whatever it was before.
Actually, before we introduced this reconciled failed state, the adapter wasn't touching at least the reason and also state at all. And actually, the reason is stored implicitly, because we know if there were flows installed or TP tag profiles, or if the ports were active. So we know what was actually was the reason before the reconciling case. So but regarding the operational status, we have to check how to deal with this. But regarding the reason, we know it implicitly by the data stored.
Yeah, but if we know the reason, the state reason or reason state, whatever, then we implicitly or indirectly also know the opera state.
Yeah, you can derive it from that. You're right.
I gotta admit, I'm a little concerned. Well, I'm a little concerned that we're going to reset a state based on what we persisted when we don't know what's necessarily changed because of a restart or whatever. It seems like if going from unknown, we need to go all the way back to the device, and the device through the adapter needs to be able to get the truth and not necessarily what was last persisted.
Well, but the adapter keeps communication with the device during this period, right?
If the adapter restarts, then the adapter loses communication to the device, and so anything in etcd has to be resynced from the device. Yes,
and it is done. It's already done. Otherwise, there's like no point in reconciliation.
Yeah. So when the adapter restarts, it checks its data against what's on the device, and then it can update the operational status.
It does, David. It does. It does through an MD check.
Okay.
So as long as the device state is enabled and the adapter is able to make contact, communicate with the ONU device, the operation state is active. I mean, there is no enabled or some other operation state if it can still make communication.
I just checked it. We set the connection status unreachable when we start the reconciling.
Yeah. The problem is that with gRPC, the reconcile doesn't start.
It's not started yet. Yeah. It's before,
Yeah.
right? Mm-hmm.
Yeah. So the test actually passes because we haven't set that unreachable state yet.
But the reconcile device RPC will be the first communication towards the adapter, right? So we do not have any chance to set anything before, right?
Yeah. That's why we were arguing that the core should set the state to unknown, and then when the device is ready, it will set the state to unreachable and reconciling.
Mm-hmm.
Makes sense?
Yeah.
Just to clarify, so it sets to unreachable, to reconciling, and then to an appropriate state after it has been able to establish or not connection with the device. Is that correct?
Do we have a reconciling state in?
So guys, I think that if the device is already setting the state to unreachable when the reconcile starts, then the adapter is also resetting the state to an appropriate state once it's done.
Yes.
So
yes.
all we need to do is to change the core to set that state to something that is, I don't know what's happening because the adapter is not there.
Oh.
And then everything will work in the same way.
Yeah, I agree with this too. So I think only the change in the core to unknown should be enough. At least the test should prove if it's enough.
I'm still not convinced because we might speak about different states. So we spoke about the connection state now, which is unreachable, and you might need the upper state as well. So maybe something is to be done in the adapter additionally.
Honestly, I'm fine with changing any state, but yeah, I see your point.
I mean, we could to prove the point that we are making, what we could try is changing the connection state to unreachable from the core perspective, because actually the core cannot reach it. If this is the case and the test passes and we found the reason, then we put in place the bigger change of unknown and the adapter reporting the actual operational state. Does that make sense?
But does core has the ability to detect that the adapter has gone?
The core, yes, because it does not reply to his messages anymore.
But what is the exact trigger of the reconcile device RPC?
It is a register message. I mean, when adapter comes back, it sends a register message to core, so core decide to reconcile it.
Yes.
Okay.
But as far as I know, when the adapter goes down, there is no indication for RW core that the adapter has gone. I mean, so.
David, is that correct?
Try that again.
Is it true that the core doesn't have any knowledge about the adapter being gone until we actually have a call to it that does not get answered?
I don't believe there's a heartbeat.
Okay, we need to make it. We need to
in any case, this heartbeat would also be too slow because adapter comes back after 3 or 4 seconds, probably.
It takes longer than that to connect. I'm not sure why.
Maybe because it waits for the ready state of the adapter.
Yeah, correct.
Your finding was 20 seconds, or how long was it?
I think it takes around 45.
Okay, it seems to be longer than before. Okay, don't know why.
Okay, so let's do this.
So anyway, I don't know how, but at a certain point, the core knows that the device is in reconciled state and is trying to reconcile it with the adapter. Because we see in the in the test that the core refused to disable the device because it is in a reconciliation state. So somehow the core knows. I don't know if it's a heartbeat or something else, but the core knows.
If the adapter has gone and come back and registered again to the RW core, then other RW core knows that it needs reconciliation and send reconcile for each device to the adapter. So after adapter came back, RW core knows it's in reconciliation state. But before that, I mean, during the time that adapter is down, I don't think RW core aware of this. I mean, at least the previous implementation was like that, but I don't know if with gRPC something changed or not. But in the previous implementation,
yeah, no, I don't like actually. That. So I don't think that has changed, and you're right. But so the point is that when we restart the container restarts fairly quickly, and the adapter re-registers fairly quickly. So they know, the core knows that the devices need reconciliation.
yes.
On the other side, the core is not able to start sending requests to the adapter until the adapter state is in ready state, because that's when Kubernetes will actually bind the service to the adapter, and that's and only then the core can establish the gRPC connection.
Do we already have some kind of buffering mechanism where messages which are the RW core is not able to send to the ONU adapter will be buffered until it is back again?
No, we don't want one either. If we're going to do buffered messages, we might as well go back to Kafka. That's what essentially that was, right?
But this would solve a lot of problems we have currently. Also, for example, for this reconciling test case from disabled device, where we do not get the flows before we go, before the adapter goes, and the flows goes into the blue or into nil, and we do not get this that the flows have been deleted before the adapter was gone. And if the RW core would then repeat these messages, then all the problems were gone.
Essentially, well, the part of the problem is that the core was saying, hey, as soon as we got a message, we assume things are good, and that's an incorrect assumption. So even if we went back to Kafka, we have some what I could call some truth issues around the code, right? Because we're telling ONUS one thing when what we really mean is we just received a message. So just going back to even a rebuffering and resending, it's not even, I wouldn't say that's the right solution, just because we're not reflecting the actual state. We're reflecting what we hope the state will be eventually one day.
We could with this approach probably we get into trouble when the adapter will go in the middle of the configuration of the flows, for example. And these flows will not be repeated when the adapter comes back. Then we will have an inconsistent state between the configuration and in the ONU adapter and in the core.
Right. I mean, the problem is when ONUS gives us a request, gives Volta a request, if Volta cannot fulfill that request because it can't get to an adapter, it needs to report that back to Volta that request is not happening. It's failed.
It means that ONUS will repeat it then, or?
ONUS will repeat it. If there is a flow in ONUS, until the device returns that flow exists, when ONUS say, hey, when ONUS asks periodically, what flows do you have? It'll be in pending add, until until the device repeats back to it that I have these flows, at which case it'll go to added. So I don't think we want kind of this 2-level repeat where ONOS is trying to ensure everything's good, and then Volta is trying to ensure messages are repeated. We should have that driven by ONOS. ONOS is the master of what flows should be there, and the master of repeatedly asking for those flows to be set.
Agreed. I agree with David here. We try, we fail, we report that we report in the stats that the flows are not there, ONOS retries. And this goes on and on and on until we make it, or we leave them in pending add and the operator makes a choice of removing the subscriber, thus removing the flows, thus we send a flow delete to Volta. And well, then really nothing happens because the flows were never installed.
But then we should also not have a problem with this test case where we kill the adapter in the middle after the disable of the ONU device, right? Because the current problem is that the device will be disabled, the ports will go down. Okay, this will be recognized by the still living ONU adapter, and then ONU adapter will be killed before the flow deletion is sent to the adapter. And shouldn't this deletion be repeated by owners because it was not executed by the or could not be accepted by the ONU adapter?
We should probably report the flows. It's a good point. I would have to check how.
If ONOS asks for a flow to be deleted, and then when ONOS then asks the device, what flows do you have? If that flow is there, ONOS will redelete that flow.
Yeah, because there is a pending add, there is also a pending remove, and that is what we use as a trigger to continuously remove the flow until it's actually removed.
Yep.
Unless, but David, have you checked that this is the existing behavior? That I mean,
I've seen this behavior in the past. I mean, I haven't checked in the past week, but I've seen this behavior. Basically, ONOS tries to reconcile what should be on the device, what is not on the device, or sorry, what should be on the device and what is on the device, and then we'll remove flows that should not, add or remove flows depending on what needs to happen.
Yep.
Yeah. The only caveat I've seen to there is a setting in ONOS that says when I connect to it, if there's already flows on the switch, I'm just going to grandfather those in.
Yes, but we don't set that. So there's actually two, David. One is allow external flow rules, which is just permit them to be there, but don't import them. And the other one is import external flow rules. And if you set both of them, the import external flows will actually bring in the existing flows to ONOS. But we don't set those. We never set those in Volta. We thought about using them for some like ISSU of ONOS, but we never ended up doing it. So we're not setting them.
Okay.
Okay, so I think we have enough information to proceed on the test and see where it leads us. Am I correct?
Andreas, should we then leave out this reconcile from disable state? So we accept that this is failing and it will be gRPC will be merged anyway, and then we have to think about what to do. Because I think we need a concept discussion about this. I wrote in Slack that actually only repairing this one thing that the TP is gone after we come back.
No, but
hold on. Then
wait, that's not a gRPC thing.
That's the new OLT. Yeah, that we need a discussion on. Keep it aside a little. Keep it aside for a second. Keep it aside. Most likely we will not get to it today, otherwise we make a huge mess of ideas in people's mind. So let's stick to gRPC. For the gRPC move, the test, we can change it. We can change the device state to be unreachable, and we can see maybe moving a little bit of things around in the test if that is enough. If that is enough, we then consider the unknown state to be done by the core, and we make sure that the adapter reports the proper state after it's rebooted, restarted, and reconnects back. Reconnects back, tells, okay, this is the state I have for this device. The core sees, oh, I had it as unknown. Let me put it back to enabled, disabled, whatever. Okay.
Okay, that means you will try to fix it with this approach discussed before, and no further changes in the ONU adapter, right?
Well, if we do not report back the state upon reconciliation success, we will need to report it. But that to me is a fairly small enough fix that we can do it.
Okay.
David, Theo?
Sounds good, yeah.
Yeah.
Okay. Good. Good, we have progress on this. Okay. Great. So the next item was on the agenda is actually talking about the MCI libgo update, but that to me is not really something that there needs an update unless Chip or Michael had something to say.
Yeah, I just had a real quick question.
Okay.
I've got most of it working, and I'm doing the unit test and handling the extended set capabilities. And the question is should relax decode be on by default or not? And on by default, I mean, is if it's on it and you decode, it'll always decode, past, coding errors in the sender if it's smart, but it's not, should not impair operations. So for the main case we're doing it, it's in case there's attributes added due to future versions of the standard. So future versions of the standard should be, we don't want to die out if that happens. And there's also an existing relaxed decode on a GET response in the NEG that we already handle, where some ONUs don't properly code their GET response, and we already have that capability. And I'm sort of leaning towards having it on by default, since it is a decode, and in networking, the receiver needs to be as lenient as it can without causing a serious error.
Yes,
Yeah,
that's what I also would think.
Yeah,
Okay.
same here. So have it on by default. Have it on by default. Can we make it a configurable property? Yes.
Yeah, it's actually is a configurable property. I was just wanting to check to see what the default should be, because if we get general consent, I didn't want to have to do a patch set.
Yeah.
Okay.
No, totally get it. Yeah, have it on by default.
And everything will be well documented in the README, just so that people know.
Good. Thanks, Chip. Much appreciated. Okay. So the next topic we have is the queue-based processing of the TP messages and flows. So Girish has a patch. I know Michael took a look at it. Any thoughts you want to share?
Thanks, Michael, for we had a chat on Slack as well. He had some valid comments. I haven't taken a look at his latest comments, but I think he had a valid point that we serialize on a per uni basis than the current implementation that serializes on the per ONU. I can make that change, but I haven't taken a look at his latest review comments.
Yeah,
Okay.
Girish, I made some comments on the patch as well, not only in Slack channel now. So perhaps you have a look at them. So basically, my impression is that it should work and should be okay, but maybe on some points, some considerations can be done. So if you take a look at the comments there, then you can either ask me back or make your decision on it.
Sounds good. Thanks, Nikhil. Another point, that important point, was that this is the first step. Once this is merged, as a second step, we should simplify a lot of code that is around the VLAN FSM itself, and try to simplify that. As that may not be needed, given that we we have taken some of this complexity outside of that VLAN FSM module. So we could simplify a lot of code that uses a lot of locks and things like that. We could discuss those next steps once this patch is merged.
Okay. Yeah, I agree.
And this patch consistently passes on scale, and it passes on the hardware for all the workflows, all the test case pass. So in general, I would say that this is not breaking anything.
Okay. Good.
So Girish, perhaps one major question which might be of interest also for other persons, the request to generate the responses from the sequential processing is that the prerequisite for ensuring the correct ordering of the flow configuration from the RW core, or has that some other background?
Well, we need to send the response, otherwise, ONUS has a wrong picture of what flows are installed and what failed to install. But that has no implication on read-write code trying to order the flows. I mean, read-write code is not ordering any flows at the moment, but ONUS, makes use of batching to ensure that flow adds are all completed before flow deletes are sent. So, that way ONUS batches the set of flows, and read-write code pushes these flows as they arrive. But OpenONU Go takes care of serializing these flows one after another.
Yeah, but we have seen in the past that the sequence was not correct ordered from the perspective of the ONU adapter, for sure. And you already sent me in Slack that some changes are done to RW core in the, I think, OLT app to ensure that sequence. So my hint would also be that because there are some dependency in your changes now, to have really the correct sequence. Otherwise, in some cases, the flow configuration would not work. And therefore, my proposal would anyway be to merge this change only then when the correct sequencing is done by RW core and the OLT app. Yeah, or we might face again some errors in our regression tests with sporadical errors, as we have seen before. And we can also live with that with the after merging, and then we have to find out what might be the reasons in perhaps RW core or the OLT app for the sequence problems.
Yeah. So it's not the rewrite core. Sorry if I gave the wrong message there. I think the new OLT app and the OF agent change is already merged to handle batching properly. I think so. The OF agent change was merged, and the OLT app that Tio is working on, has some more improvements to implement this in a batching in the right way. So my change, it's not critical to merge this, right now, because there are so many other things that are going on, like gRPC stuff. Yeah. So once that is merged, we can look into this.
Yeah. Okay. On the other hand, I would also say, of course, it's better to merge it as fast as possible. But yeah, that's also a question more to Andrea for the sequence of ONU adapter merge of patches.
Yes, that's a good point, Michael. Thanks for bringing it up. As I said before, we have 1 week to fix the gRPC stuff. Hopefully, we get this gRPC things all said and done in 1 week, and after that, we will merge the gRPC and further merge this fix here, and then start working on the new OLT app and also the other core change that Theo has for the flow sequencing. So this is the order that I have the plan. If by 1 week we are still stuck on gRPC, we will have to make a decision at TST. My thinking is that we should probably move to merging at least a few of these things. But it will not be just my decision. It will be something that will need to be discussed at TST. And I don't want to spend any time right now on that because there's no point. I'm crossing my fingers that we will have everything ready by next week. So we don't have to have that discussion.
Yeah, okay, fine. So we will see next week what the
yes.
situation is.
Yes, precisely. So further thing is on the software update, the download status and things like that. I had a discussion with Michael and the agreement was that we will revert back the use of the download state as kind of an operational state of the upgrade. And then we can bring this as a requirement in the protos and make changes there as needed. But we will revert back that in master. And after that is reverted back on in master, it will also be removed from the 2.8 patch that is existing, that includes some of the fixes that were there to adjust some of the states, especially, and the return and the reporting of these states to the northbound, and that patch will merge. So that is the decision that we're having on this. Michael, did I forget anything?
No, that's correct. I think that's also complete view on the proceeding.
Perfect. Okay, great. So on the PM counters and the loggings, both patches are up. Thanks, Holger, for rebasing that, and thanks, Imani, for submitting the few things and rebasing those as well. These are one of the patches that are on the train behind the gRPC merge. Both of them are to be merged after we merge the gRPC stuff, hopefully next week. And to be fairly sure, this is not functionality impacting. So this to me can go in effectively as soon as we merge the gRPC stuff, and maybe Girish's patch not to have a huge rebase issue on that one as well. The PM stuff, it's not super urgent. It can wait also because it has a proto change. So I want to go a little bit slower on that one. Okay. On the VoIP, we had a little bit of a discussion yesterday at the TST on this one. Mahir, just give us some thoughts.
Okay, we don't have too much time, but I want to quickly go over the document to give some hint to Michael because he wasn't, here when we reviewed this document. So this is about to giving the VoIP service on the ONUs, on the POTS ports, plain old telephony service ports. So there are mainly two kind of changes to be done in the system or in the ONU adapter. First one is to discover these new port types. And the second thing is to configure a service, a VoIP service on these ports. So create the appropriate MEs on the port. For port discovery, we decided to change this new port type and advertise it to the upper layers to RWCAR and to SDN controller with changing its features and its name. So we decided to, or the proposal is to add some suffix to the port name, and also define a new feature for this port. And when we talked about the features, we decided to the current Ethernet UNI port types are fiber and 1 gigabyte full duplex, and we decided to change it to copper and other for the POTS ports. We didn't discuss about this, Andrea, but during this name generation, there's a suffix in the port name, which is the UNI ID also currently. So it's like 1, 2, 3 for 3 ports UNIs, for example. But if we have both the UNI and ports, it may be, for example, for 3 UNI and 2 ports, it may be 1, 2, 3, 4, 5, or it may be 1, 2, 3, and 1, 2, 3. So each type starts from 1 in its port type. So the requirement from operator is to show them like 1, 2, 3, and 1, 2 again. So I also propose to change the name, the ID in the name,
secondo me con anche
like
il
that.
traffico, così meno di 2 ore e mezza non ci mettiamo a tornare e poi dobbiamo lavarci, quindi ti direi non prima delle 8 e mezza, ma forse anche 9. Mi spiace perché ci avrei fame, però prima mi sembra molto.
Okay, let me go ahead and do the configuration. Talk about the configuration, ME configuration. Can you scroll a bit down?
Yep.
Andrea, yeah. Yes, these are the main MEs associated with the POTS ports. All of these MEs are corresponds to the MIP download stage in our final state machines in ONU adapter. So we're going to create all these MEs in MIP download FSM, but currently in this there are some information should be configured into the MEs, like SIP proxy address, SIP proxy port, and username and password, etc. We don't have the information here to configure this in MIP download stage. So this MEs should be created first in MIP download section or stage. Then during the flow of insertion, we add to set the parameters like SIP agents, data, and proxy information, etc. So here there are mainly there are two approaches here. First, configuring all these MEs in MIP download stage, and then set the appropriate values during flow insertion. The second one may be an alternative to not to configure the ports that we haven't given a service to, unused ports. We may remove all these MIP downloads configuration into the flow FSM. So during flow insertion, we can both create and set all these MEs and the unassigned configuration also. So these MEs are, I think, all of them are implemented by Cheap. So now we started with a patch which discovered the ports in ONU adapter. Özge uploaded a patch, so it's in review, I think. So the next we will go to a new patch to advertise these ports to RW core and upper layer, according to the discussions and decisions we took here. Then later, the ME creations and the FSMs will come in different patches. Okay. So these are the changes in ONU adapter mainly. If you guys, go through the document and review it, and if you have any questions, we can discuss them and continue accordingly.
Yeah, I've seen the patch that Oscar has delivered. So I understand this was an initial patch for this implementation to mainly notify the hotspot to the system. I think Andrea already has merged that, or generally this patch was merged. And before I had a look at it, I still made some comments on that after the merge. So perhaps someone can also have a look on the comments, even though it was already merged. I still have some doubts about the indications that are delivered then according to this patch, mainly because you also mentioned here the type should be copper. I'm not sure if that is already the case with that patch. And yeah, things like that. So maybe someone could have a look at the comments as well.
Yeah, of course. Even I didn't know that it's merged, but even if it's merged, we can address your comments in the next patch. As I said, we will have a few remaining patches, so maybe we can address them there. But about the feature, putting copper there. Actually, we discussed this in TST, and there is no, say, related value in OpenFlow for this kind of ports. So it's kind of, we had to do something like that.
Mm-hmm.
Yeah, so the decision yesterday at TST was to have the existing port to be moved to copper and 1 gig full duplex. Where is it? Yeah, this one. In an OR pattern. Instead, the POTS port to be copper or other. The OR is an actual code OR, not all the meaning. Or of the two values. That's what it is. So in this way, we can actually distinguish between two copper ports, because both UNI ports and all UNI ports and the POTS port are copper, and then the type, the 1 gig full duplex or the other, is what we then use for distinguish. Okay. Guys, please review this. We are at the top of the hour, so I think we can close for the day. Thanks a lot for joining. It was very useful discussions. Sorry, Torsten, we didn't get to the testing today. Maybe a small sentence. Thanks for the patch on the Volta PM data on 2.8. We forgot about those. We're now testing PM and alarms on 2.8 as well. And thanks for that. So let's talk again next week. And thanks a lot for joining. Let's continue the great work on the OpenONU Go channel and the mailing list. And if please you can help the gRPC move, that would be great. Thanks everybody. Cheers. Bye-bye.
Bye.
Bye.
Bye.